Upcoming, I'm excited to welcome Phong Nguyen, Chief AI Officer at FPT Software. Phong received his PhD in engineering at the University of Tokyo, Japan. In 2019, he was a visiting researcher at the Mila Institute of Artificial Intelligence in Quebec, under the direction of Professor Joshua Bangio, winner of 2018 AM Turing Award, awarded by the Computer Science Association and considered as the Nobel Prize in the field of computer science. At Mila, together with Professor Joshua Bangio and Professor Aaron Corville, Phong researched many projects on disentanglement anomaly detection and reinforcement learning. Phong is currently the Chief AI Officer of FPT Software, where he is playing a leading role in formulating their AI strategy. He sets up many research teams for fundamental and applied research topics like reinforcement learning, efficient neural modeling, representation learning for code, sound-based intelligent inspection, and computer vision-based OCR and image generation. Furthermore, Phong and his teams are also working on developing AI products and solutions to serve customers in multiple industries such as manufacturing, automotive, and human resources. Today, Phong will share with us his experience on the data-centric approach, the future of practical AI. Phong, over to you.
Thank you very much, Eric, for your kind introduction. So again, thanks everyone for letting me speak in this event. So I would like to share my presentation today with the name Data-centric for practical AI. So as the introduction have mentioned, I used to be a researcher and work for many years researching AI, and I understand the importance of AI in academia. However, when I'm moving to industry, my purpose has shifted from research to build practical AI. And I want to share with you the difference between research and industrial AI. So at FPT Software, well, we are the biggest IT service company in Southeast Asia, headquartered in Vietnam, and we're providing our services to many clients all over the world. We want to build machine learning and artificial intelligence product to serve our client and to improve our productivity. So there's a few approaches I want to share when we want to turn machine learning and AI into production. The first thing is you need to combine research into your production. So as I have worked many years in research, I understand that the pace of research is really fast for AI. One day you have a machine learning model, a neural network understand a language model. The second day you have another neural network understand vision, understand the pictures. And then boom, the next day you have a machine learning model that can generate text from image, so image captioning. And then the next day you will have a generative model that can generate images from just a few words, from just a sentence of natural language. And fast forward recently, just last week, the latest research showed that we can even generate the whole video clip with just a description from natural language. So to stay competitive, you really need to incorporate research into your production operation. The second approach is how important it is to operate your machine learning and AI environment in a stable production environment. Hence, ML ops or machine learning operations is a very important framework if you really need to adopt machine learning into industrial application. And finally, the third one is focus on data-centric AI approach rather than model-centric AI. I will explain about this point a bit later. So the challenges when we try to produce as many as possible AI productions, um, we face some of the challenges. From research to production, there's a lot of difference. First of all, in terms of talents, for production, you require a lot of different skills. To produce an actual application, you will have a person with a very practical mindset, trying to solve the problem um, as uh, as much as possible rather than study the problem. Um, and the people will have to try all the methods to solve the problem. It doesn't necessarily, sometimes it doesn't necessarily to be machine learning on AI algorithms, but at the end of the day, the final outcome is more important. The second challenge is I always face in industry is data and quality of data. Um, in research, we always have benchmark data set, which is already provided by someone else. However, in industry, measure of data are not ready to be used for machine learning. So a lot of corporations and companies nowadays are still trying to build their platform and verify their data quality in order to apply machine learning and other analytics framework. And the last part is the automation in AI and ML process. So in order to mass and to produce the algorithms and the application to scale up, um, we need a lot of automated tools to work with AI and ML. And at the moment, there's not many tools that support that. So tackling this, the data problem, that is the major problem, the most important problem that we face in industrial application. So I would like to share my viewpoint on data-centric AI approach. So conventional way of approach at AI is usually you would try to improve the motor of the AI so that it can be more robust, it can be more intelligent, and it can improve the accuracy of the AI motor. So it's called motor-centric AI. So you can see on the left side of the equations, AI and ML has two components, code and data. So we will work more on the code, on the algorithm itself. However, remember that in the equations, we have code and data, right? So if we shift our attention to data, we will have data-centric approach. So in data-centric, we will ensure the quality of data. We will ensure the variety and the fairness and all type of data, which is more accurate than without any noise or without any uh, outliers in the data. So why do we shift our attention to data centric? In so ML in research and ML in productions are very different. Like I have just mentioned, right? In research, so the requirement is to concern the state of the art of the motor performance on the benchmark data set. So the data set is fixed, and we try to improve the motor. However, in the productions, the requirements of the stakeholder is more important. Like I mentioned, the outcome, the ultimate outcome, is the most important. Um, and also, in terms of computational priority in research, we will do fast training, high throughput. While in production, we will try to have a fast inference and low latency. In terms of data, in research is usually often static, but in productions, so data constantly shifting in distribution. That is very normal because, for example, if you are using an AI to inspect the products in a production line of a manufacturing companies, so there's different type of defect, and one day your AI can detect very well some type of defect, but then with your feedback, uh, they the manufacturers can improve the quality, and there's less and less that type of defect in the production line, and there would be an increase in another type of defect, which is maybe a new one. So your AI will have to fix a constantly shifting in distribution in production. And we talk about fairness, we talk about interpretability, and we talk about scaling, which is also very different between research and production as well. So over here, I highlight the data part, which is usually the most headache and a very important aspect when we deal with AI in production. So over here is a framework for an ML system provided by a very big company. And if you look at all of these components, data is often the biggest challenge for developing and deploying AI. It is showing that over here, the data pipelines, the number one, have the largest portion in terms of the other process. For example, motor pipeline and deployment pipeline. If you work in the machine learning and data science field, I think you always hear that to deal with data and data pre-processing is usually consumed of 80% of the time of a data scientist, and it is still true in production. One more thing is, why do we shift the focus to data centric? In industrial applications, so trustworthy AI will require trustworthy data. We always talk about the concept of garbage in, garbage out. So it's very true when it comes to production ML. Some of the issues we usually have to fix when it comes with data quality issues, including label mistake, new labels, missing data, or noisy data, gaps in the coverage or imbalanced classes, data constantly shifting, and production ML system need quality training data at the scale. We may have a very small quality data, but when we have a large data set, then it's more difficult to have high quality data. So I would like to introduce our approach in data-centric AI. Well, we need to build a strong AI foundation from various data pipeline and data technique. So from data ingestions, data governance, data quality, data storage, data processing, and data consumptions, you need to incorporate all of that into your system. You have to work with data warehouse, data lake, cloud data lake nowadays, and even hybrid multi-cloud data AI platform. So everything's will start as at building a strong data foundation for AI system in the future. And we need to create processes in order to ensure the quality of the data. From identify and scoping, you need to understand the business problem, identification, and validation. So you need to identify the business problem. You can ask the question, can AI and ML solve it? And why do we need AI and ML? And we move to data capture and ingestions. So we have to ask ourselves which data is available, how much data is needed, how much to collect data, or how to collect data. And we move to the part of design and development. So data structuring and integrations, from data cleaning, data transformation, data annotation, labeling, and data quality check. And move to data strategies during training with the data augmentation, feature engineering, data versioning, continuous learning, domain knowledge. So data strategy during training is a very important part of data-centric approach, because it can help you, first of all, to work with a limited data set, and second of all, to ensure the model will have higher performance and accuracy because of the variety of the data that it learned from the data augmentation, especially for the image data. And after we train the model, we need to deploy and monitor it. So that's important for data audit and monitoring. We need to monitor error and bias. We need to monitor the data drift. And more importantly, in some of the industrial application, it's very important to have explainable AI, where you use many techniques to unbox the AI black box. So here is an example for an architecture to operationalize ML and AI systems, from acquire the data to organize and analyze to deliver. So at FPT Software, we always promote data-centric AI in order to solve all the practical problems. We recently we host a data-centric AI competition in for the community all over the world, and Vietnam as well, to compete with each other and to develop techniques for data-centric AI. So regular AI competitions usually provide us data and ask the participants to search and optimize the models to get the best performance, and the results is evaluated on the model performance. But our data-centric AI competition focus on the developing all the techniques for improving the quality of data. And the name of the competition is called Data Comp. Is hosted developing a fixed mask model which contain three objects categories: wearing masks, not wearing masks, and improperly wearing mask. So in this competition, the candidates will be given a collection of data set as well. But the difference is we give them a fixed model, and the aim is to improve the performance of the model by applying the data-centric approach. I would like to show you some of the results of the competition. Becomes top performance in a very short time, and it was the competition was very competitive. So we this is some of the some statistic of the competition. So around more than 1,000 participants in Vietnam, and also 130 participants joining us from overseas. And there's various effective augmentation techniques were discovered and were shared during this competition. So a data set was divided into three sub data sets, like I have mentioned, and we keep the evaluation data set so that it's fair for everyone. And some of the technique very popular for improving the augmentation of the data is, for example, like blur, contrast, zoom, and HUE, crop, translation, mosaic, rotation, edge case, mix up, and cut out. So all of these will help the performance of the motor improving very dramatically. I would like to share another example where we apply a data-centric approach to our data science project within FPT Software. So data-centric steadily enhance the analytics and predictive outcomes over time via adding more data resources. Feature engineering, feature selection have the best feature collection for the predictive motors. In this case, our data keep evolving, and feature engineering is one of the part that is very important, that we ensure our motor have the best the features possible. So from the data, we keep evolving and keep research more on the feature engineering to have a high quality features. So a few part that we can see how it improving in this year. Our data science project in a problem that have been improving in terms of accuracy. So it is a project within FPT Software. We try to predict which employee whom will quit the company within the next few months. And our motor is keeping improving the accuracy and with our data-centric approach, and it will going likely to keep improving in the future as well. One more another example I would like to give is another project that we have for our AI's project is everyone heard about OCR, optical recognition characters recognition. So in OCR case, we want to recognize the handwritten characters rather than the printed characters. And in order to get the data to be to improve the quality of the data preparation part, we need to ingest provided data from the clients with the fixed data set we already have. We also add external data from the internet. We also generate synthetic data, which is a very important part to improve the accuracy of the motor. And of course, the augmentation technique that I have mentioned in the competition part is also helping us to improve the data quality. So data labeling and cleaning also a very important part, because in the data set, there's potentially many mislabel. So label new data set, correct the label wrong example, and also correct the confused label samples. Sometimes it can help the algorithm to learn much better. And for that, all of that technique that we have tried, the accuracy of the motor and has been improving, and the word error rate has also reduced. You can see here with feedback classification, the word rate has is from 25 to 5%. With Vietnamese speech recognition, we also have the error rate from 15% to reduced to 9.8%. And for handwritten recognition, we have just mentioned the error rates have reduced from 3.4% to 0.16%. So all of these is only done with data-centric approach, and we don't have to investigate and push too much on the modeling part. And in the modeling, we usually follow the state of the art of AI motor has been published in research. So a few takeaway that I would like the audience to know today. Um, Data-centric is a key part of practical AI and ML. And in data-centric, model performance is achieved by tuning and improving data quality while keeping a constant AI and ML algorithm. In data-centric AI approach, data quality must be maintained and improved in all the stages of AI and ML project lifecycle. The world is very dynamic, and our data is keep shifting. So, data-centric approach, I believe, is a future of practical AI. Thank you very much for your attention, and I hope to receive the questions. Okay, so I have seen a few questions over here. Um, Let me pick a few questions and let's talk about it. The first questions I think I can answer is AI can be adapted by almost all industries. But today, in which industry do you think it will be more beneficial for the people and at the same time maintain its sustainability and maximize its benefits? So it's a very interesting question. So at FPT Software, we use AI and ML in various industries, from banking to manufacturing to education, and we also use it in all the many functions. Functionality of an organization, from HR to cybersecurity to finance and to sales. So what I it's just my honest opinion that I think AI should be applied in manufacturing industry, um, and because as we know, AI can help a lot with automation, and in manufacturing, the more automation, the more efficient it can get. And also it's beneficial to all the people because usually in manufacturing, all the work are usually repeated, and people can be released to a very high value work like design, and to ensure the quality of the product rather than you repeatedly doing the repeated work. So I think AI applying in manufacturing would be very suitable.
Thank you very much for that, Phong. That was very, very well said. Actually, I'm very sorry, guys. I had a technical issue with the microphone, so you couldn't hear me. But anyway, I'm back. And well, I just want to thank Dr. Phong Nguyen for this exciting presentation and the projects that you guys are dealing with right now. Yeah, actually, I do have a question that I would like to to ask for this session, if I may, Doctor. We've heard that this type of research is going to be instrumental in developing AI products and solutions that will serve customers in multiple industries, including manufacturing, automotive, and human resources. Can you briefly go over a few ways that advancements in AI can aid in reducing production time and cost in some of these industries?
Sure. So at the moment, our AI is production is focusing on reducing the error rates and in the manufacturing factory. So as you know, that computer visions and others technology like time series data like sound and sensors IoT data has been studied very carefully and well studied in academia especially for machine learning and AI. And the inspections part for product is a very important process in manufacturing. So we are helping manufacturers and lots of factories to detect the defect product in advance so that it doesn't get shipped to the customer, and it prevent the damage in branding. It prevent the cost for recall the product, and it also safer for users who use the product if they don't have to use the defect product. So in human usually have vision to see the product and to hear the product if it's work well, or to sense the product, like its vibration, its temperature, and everything. So AI can actually augment those intelligence and can give a warning in advance. In another part is, for example, like human resource. With all the data can be collected, we can understand the happiness of the employee. We can improve the region where employee is not happy and having concern, and human resource can address those issues in within the organization very quickly with data driven. And also it can predict if the company, if the employee want to leave the company, so that it can bring a better environment of work to the employee. So those are some of the example that we can use AI to help.
That's really impressive what we can do with AI nowadays, right? Actually, time is short, and we have a lot of questions from the audience. And I would like now, Doctor, if you may pick a question from the questions that we have here from the audience as the most interesting one or the most relevant one. We have a lot of them. So if you can just take your time, scroll up and down, go read the questions, and we can pick the most interesting one and prize that question.
Sure. I would like to pick a question from a person named DAT. So he asked, what do you think about the use of synthetic data? How are they compared with the real data in training AI and ML models? Given finding good quality data is not easy, especially in healthcare industry where you have to meet many regulations. The question is really interesting. I would love to write him an answer after this seminar, and we can discuss about synthetic data, since it is a very important topic for data-centric AI.
There you go. We have a winner. Thank you very much for sharing your questions. And thank you very much, Doctor, for sharing your knowledge and for sharing your time and effort in being here with us at this worldwide AI webinar. To the audience, please let me remind you that we have the networking lounge where you can share your opinions, you can share your knowledge, you can we're trying to create this community of AI enthusiasts, practitioners, and so on. So please go to our networking lounge and share what you have to say. Thank you very much, everyone. Stay tuned. We're coming back with the next session. Bye.